So in the previous video we saw what is a distributed blockchain and why they pair A, B, C, etc. They represent different nodes in our blockchain. The next bit is to have a look at the tokens. Now, each token essentially represents a set of transactions, all of them done in the sequence of the blockchain. So for example here, in this example, I gave $25 from Darcy to Bingley, $4.27 from Elizabeth to Jane. Now, what these actually represent, those names in here, they actually represent your account, your wallets with Bitcoin, Ethereum, or whichever currency you're using. Everything else works exactly the same as we saw in previously in distributed and blockchain. The only difference is that the data, instead of being a generic blob, is this structured set of data with more or less rows. And if here change any of the values, then of course the hash value of the block changes, therefore changes the hashed value of those blocks. But now what you might wonder is, if this is plain data, how do I make sure, and it's distributed as well, how do I make sure that when I give money from one account to another, I actually take the money from the right account and it comes to the correct account if everything is public? Because as you remember, each person in this distributed network actually has access to the entire blockchain with all the transactions. So the way this is handled is through something called the public and private key pairs. So there is an algorithm called the elliptic curve digital signature algorithm, which is the one used by Bitcoin or Ethereum, but also digital signature algorithm, which is essentially the same one that is used by Git, if you guys are into programming. And what actually happens is that you have this set of keys. So we have a private key, which has this number, and there is a corresponding public key. What happens is that this public key is meant to be public, okay? And there is one private key that you have to keep for yourself. Now, if I'm gonna generate a random private key, okay, as you can see, the public key always changes. How can I use this public and private key? So the way I'm gonna use it, this is basically the salt that I'm gonna use to sign a message, which then I take my public key. There is a demo actually. So if I go to the signature tab, here I have a private key. That's my private key, which as a corresponding, I have a private key and a corresponding public key. When I go here and I write a message, this message, for example, hello world, is going to be signed with this private key and the public key. So what happens is that this is the signature of the message. Now, what I can do, I can actually verify the message. So I take my public key and the signature that has been done through my private key. And what I can do, I can actually verify that this message with this public key and the signature actually belongs to, has been signed correctly. So I can verify and I can tell that this message is actually mine. Now, if you wonder about this public key and the signature, there is it's a very complex computational problem which cannot be solved in a reasonable amount of time. But reasonable, I mean, it's gonna take years and years to actually solve this problem with today's technology, which is why this is so secure. Now, if I go, so we have a message, we have a public key and a signature, and I know that this message, it's mine. And essentially, it's exactly what happens when I go from Darcy to Bingley. These are actually pairs of message, which is our transaction, okay? And then it's gonna have a public key and the signature of the message. Now, here I'm gonna have just the signature with the public key because it's public, and I can verify they're actually true. Now, the next bit we can actually look at is then the transaction section. As you can see here, the example is I have a message, which in this case is $20 from this account to this other account, and it's going to be signed with this private key. So what is going to happen? I'm going to get a signature exactly like I had before, and this is the signature using this private key of this combination. When I go to the verify, this signature is going to be verified if it actually corresponds to the my public key, and it works once more. So we go back to the blockchain, and here, as you can see, is exactly the same. All right. So what is happening is exactly what was happening in this token demo and in the Coinbase demo. The only difference is that now you actually understand that those are signed. So we have, for example, let's have a look at this message. This is my base amount and it's into this account. Now this one is my base. Now I move money or bitcoins from this account that actually has the same hash. Alright, so this one is all the same. I move this from this account, which is exactly the same, to this account, and to do this, I use my private key, and this one is my signature of the message. And all of this is hashed. If I change any of the values in here, of course the hash is going to be different, and it's going to invalidate my blockchain. And this is everything about the blockchain and how it works with the signature. That is how we know that which belongs to which.